Hello everyone, my name is Ketawat Vamshi of Chemical Engineering Department, VNIT Nagpur. Now I am going to tell about the topic planar chromatography. What is planar chromatography? Chromatography is the scientific technique of separating a substance into its various components and compounds for individual identification. Planar chromatography is defined by having the stationary phase of a process take place on the plane. This is in contrast to column chromatography, where the stationary phase takes place inside a tube. There are two main branches of planar chromatography: paper chromatography and thin layer chromatography. Although both practices follow very similar principles and methods, they use different materials as beds or planes for the stationary phase of the process. Planar chromatography divided by two various components as actions, capillary actions and forced flow. In capillary action, thin layer chromatography and high performance thin layer chromatography. In forced flow, overpressure layer chromatography and high performance thin layer chromatography, and RPC, rotational planar chromatography. Overpressure layer chromatography. What is OPLC? OPLC as a forced flow planar layer liquid chromatography technique is based on the ultra micro chamber. It was developed and introduced in the late 70s by Hungarian scientists. Overpressure layer chromatography is powerful separation technique. It uses a solvent pump to deliver elutant into a pressurized ultra micro chamber containing an analytical or preparatory planar adsorbent bed to separate the components of a mixture. The elutant is forced to flow through the adsorbent layer at an optimum constant linear velocity. The openable planar adsorbent bed and forced flow allows OPLC to combine the benefit of HPLC and TLC to provide rapid, efficient separation using of stationary phases. This is the OPLC analytical instrument figure. Overview of OPLC. The chromatographic technique separating compounds using mobile and stationary phases under applied pressure. Key feature: applied pressure enhances separation efficiency and reduces analysis time compared to TLC. Applications: pharmaceuticals, food testing, environmental analysis, forensic science. Some basic components: stationary phase, thin adsorbent layer, example silica gel or alumina. Pressure chamber applies controlled pressure to the mobile phase. Mobile phase, solvent system transporting analytes through the stationary phase. This is the basic scheme of the OPLC technique. Here is the mobile phase. The solvent reservoir contains the mobile phase which is pumped into the system. A pump generates pressure to drive the mobile phase through the chromatographic system. Chromatographic plate, the stationary phase where the sample is applied and separation occurs. Pressurized chamber encloses the chromatographic plate, ensuring uniform pressure across the system for better separation and efficiency. Injector injects the sample into the chromatographic plate. Elutant, the mobile phase with separated compounds exist the chamber of the analysis. Detector monitors the separated compounds as they elute from the system. Recorder captures the data from the detector to produce the chromatogram for analysis. Collector collects the separated fractions of preparatory OPLC in the performed experiment. Water pillow used to ensure uniform pressure and temperature across the chromatographic plate. Working principle of OPLC. Chromatographic separation. OPLC combines the concept of thin layer chromatography and liquid chromatography HPLC, utilizing a stationary phase in the thin layer and mobile phase to separate components. The principle relies on the differing affinities of the analyte compounds to the stationary phase and the mobile phase. How it works: sample application. A small amount of sample mixture is applied as a spot or line on the stationary phase. Pressure driven flow. The mobile phase, typically a solvent or mixture solvent, is forced through the stationary phase under controlled pressure separation mechanism. The components of the sample will move at different rates depending on their interaction with the stationary phase, adsorption and mobile phase. Detection. After the components separate, they can be visualized by various detection methods such as the UV light fluorescence or chemical staining. In overpressure layer chromatography, peak heights corresponding to the concentration of the compounds in the sample. A higher peak indicates the higher concentration, while lower peaks represent lower concentrations. The pressure applied in the OPLC enhances flow rates and separation efficiency, often leading to sharper, more defined peaks compared to the traditional thin layer chromatography. Here you can see the peaks of the OPLC graph result. Advantages of OPLC: improved efficiency, faster solvent flow ensures sharper peaks and better separation than TLC. Faster analysis, pressure reduces separation time significantly. Better reproductivity, uh, precise control provides consistent results. High sensitivity, detects low analyte concentrations effectively. Versatility, suitable for qualitative and quantitative analysis in fields like pharmaceuticals, food safety, and forensics. Limitations of the OPLC technique: high cost, equipment setup is expensive compared to the traditional TLC. Operational complexity, requires expertise in pressure calibration and method development. Small sample volume, not suitable for large analyte quantities. Plate sensitivity, results depend on the stationary phase, plate quality. Time consuming operation, needs detailed calibration and method optimization. So here we can conclude that overpressure layer chromatography represents an advancement over traditional thin layer chromatography, utilizing pressure to improve separation efficiency, speed, and reproducibility. Final thoughts. OPLC offers many benefits but requires consideration of cost, complexity, and need of calibration. It is ideal for applications needing precise separation and faster analysis but not suitable for all sample types. So, and thank you.